Hello, am I audible to everyone?
College students get free Gemini upgrade for 1 year.
Good evening, good evening. Okay, I am starting the class na. So namaskar, adab, sat shri akal, kasake, 𝐂𝐤𝐴, hello and welcome in GATE Wallah. So student, in this lecture we are going to discuss vibration of 2 degree of freedom system. If you see the syllabus of GATE Aerospace na, it is clearly mentioned that in 2 degree of freedom we had to study free undamped vibration. So here I will discuss the vibration of 2 degree of freedom system, in which I will discuss the case of free undamped, because that is in our GATE syllabus. Okay. So first I will discuss its introduction. Then mainly the question which comes from this topic is the calculation of natural frequency. And in 2 degree of freedom system, now you will get 2 natural frequency. So I will discuss how we can calculate those 2 natural frequency. After that, we'll understand some more concept like the concept of mode shape and how to write displacement equation. But mostly the question which will come in regarding the calculation of natural frequency of the system. Okay. So mainly in today's class, this will be our main focus. Okay. Yes. First of all, what is 2 degree of freedom system? Here I have taken a diagram as a reference. Okay. In this diagram, 2 mass is attached. This is mass M1. This is mass M2. In this mass M1, you can see spring 1 is attached and spring 1 is fixed here. Here spring 2 is attached with both mass M1 and M2. Okay. And this side with this mass M2, spring 3 is attached whose stiffness is K3 and it is fixed here. Now, why it is 2 degree of freedom system? What is the meaning of degree of freedom? It is the number of independent parameter required to completely specify the motion of a system. Like suppose you want to find the displacement, displacement of the system. So the number of independent displacement related term is required to completely specify the motion of a system is known as degree of freedom. And in this case, I require 2 displacement. Like see, suppose if I am saying that the displacement of mass M1 is 2 centimeter, just try to understand this. It is not sufficient. See, if mass M1 is displacing in this direction by 2 centimeter, yes, it is 100% sure. This spring 1 will also elongate by 2 centimeter because it is fixed here. But can I predict the displacement of spring 2 or displacement of mass 2? No. No. Because if this mass 1 is going in this direction by 2 centimeter, what will happen now? Don't say that this spring will also move in this direction by 2 centimeter because it is not fixed here. Here mass M2 is also attached. So to specify the elongation or contraction or axial displacement of spring 2, you need to tell regarding the displacement of mass 2 also. Like suppose I am saying the mass 2 is going in this direction by 3 centimeter. This information just I am giving for understanding. Now you can completely specify the motion of system. How many information I have given? 2. How? See, if this mass M1 is going in this direction by 2 centimeter and mass 2 is going in this direction by 3 centimeter, can I say this spring 2 will elongate by 1 centimeter? Because just assume if this end is fixed, due to this motion it will contract. If this is fixed, due to this motion it will elongate. Okay, so right now this motion is more. So net elongation of the spring 2 will be 3 minus 2, that is 1 centimeter. Similarly, if this displacement is more, spring 2 will contract. But you can tell the displacement of spring 2 also. Similarly, if mass M2 is going in this direction by 3 centimeter, this spring 3 will contract by 3 centimeter. Okay. So with this 2 information, I am able to specify or define the motion of entire system. Means degree of freedom of the system is 2. Means what I am trying to say here, I require 2 display information related to displacement. Suppose a displacement of mass 1 is x1 and displacement of mass 2 is x2. Okay, I need to find their equation in terms of time. But if you know x1 and x2, you can find any information related to displacement. Means degree of freedom of the system is 2. Yes. And for 2 degree of freedom system, will get 2 natural frequency. I will discuss later how to calculate those 2 natural frequency. But right now, in this case, I was explaining how to calculate degree of freedom. So degree of freedom of this system is 2. Okay. Yes. Now, here now sometime 1 mark question can come. Very rare question you will find, but sometime question can come. here, since in 2 degree of freedom, right now 2 mass is involved. Okay, yes. So in this 2 degree of freedom system, how they are linked with each other? Based on that, we define a coupling, which is one is static coupling, one is dynamic coupling. Static coupling means if coupling is occurring due to stiffness, that is static coupling. If coupling is occurring in free and then vibration, if coupling is occurring due to masses, that is comes under dynamic coupling. But that you will understand when I will derive the equation of this vibration. So first I am deriving here the equation of the vibration. But when you are deriving the equation of vibration, let the displacement of this mass 1 from mean position is x1. Similarly, the displacement of mass 2 from its mean position is suppose x2. Right now I am taking x1, x2 horizontal right. It doesn't mean s2, mass m2 cannot displace in this direction. If it is vibrating, it will displace in both sides. So right now I have taken x2 this side now. Means if it is coming positive, displacement of mass 2 will be this side. If it is coming negative, it will be this side. Similarly, after solving at an instant, if x1 is coming positive, means it will displace this side. If it is coming negative, it will displace this side. Okay. Yes. So this is displacement of mass 1 from mean position is x1. Displacement of m2 from mean position is x2. Okay. Now see how we can derive the equation of vibration now. So for that we'll draw the FBD of both the masses. So suppose here I am drawing the FBD means free body diagram of mass 1. Just try to understand now. And okay, don't think in 5 minutes now you will understand entire 2 degree of freedom system. I require half to 1 hour complete, at least half hour time to explain this. So don't be in hurry. Okay, don't be in hurry. Try to understand the things slowly. But what will happen at last when I will complete the lecture now, you will easily find the you will be able to find the natural frequency of 2 degree of freedom system. Don't worry. Okay. Yes. But first try to understand. Don't be in hurry. Okay. At least half hour discussion is required. Okay. So here I am drawing. Now see. If I am drawing the FBD of mass 1, here this spring 1 is attached, so I am cutting this spring 1 from this location. Here spring 2 is attached, so I am cutting from this location. Okay. So it is spring 2 whose stiffness is K2, spring 1 whose stiffness is K1. Okay, I have cutted from this location. At the location from where we have cutted, at this location, internal spring force will come, which is nothing but restoring force. Okay. Yes. Similarly in M2, here this spring is attached, I am cutting from this location. Stiffness of this is K2. Here this spring is attached, whose stiffness is K3. Now we have cutted this spring from this location, this spring from this location. Displacement of mass 1 is x1 this side, so x1 dot will also be this side, x1 double dot will also be this side. Similarly, displacement of mass 2 is x2, velocity will be x2 dot, acceleration will be x2 double dot. Yes. Now first of all, I am involving inertia forces. So here mass of this system is m1, which is having translatory motion, and as my inertia force is mass into acceleration, acceleration is x1 double dot. So inertia force will be m1 x1 double dot. This is the magnitude. Now what about direction? It will be opposite to x1 double dot. And yesterday also I explained that x1 double dot we are getting by differentiating x1 with respect to time 2 times. Okay, if I will differentiate x1 with respect to time 1 time, we'll get x1 dot. Again differentiate with respect to time, you will get x1 double dot. And since x1 double dot I am getting by differentiation of x1, so the direction of x1 double dot will be same as x1. Okay, if actual acceleration is in this direction, automatically it will come with minus sign. But x1 double dot direction will always be same as x1. Okay, and inertia force will be opposite to x1 double dot. So x1 double dot is in this direction, so inertia force will be in this direction. Similarly, here inertia force, so mass of this body is m2, acceleration is x2 double dot. So inertia force will be m2 x2 double dot, direction opposite to x2 double dot. Right now x2 double dot in this direction, so it will be in this direction. So this is inertia force. Now I am involving restoring force, which is occurring due to stiffness, means I am involving spring force. Yes. So see, if displacement of mass 1 in m1 is x1 this side, so can I say this spring 1 will elongate by x1 amount? And since it is spring 1 is elongating by x1 amount, so spring force in spring 1, and this is the ability of spring 1, is K1 x1. And since it is elongating, can I say as per this information, spring 1 is in tension? Yes. So here now, if you don't want to do mistake, now see whether spring is in tension or compression right now. Okay, so if it is in tension now, so for that at this point we'll draw such arrow which is trying to elongate this portion of the spring, because I am drawing the ability of mass 1 where spring 1 is this. So draw such arrow which is trying to elongate this portion because it is tension. Now to elongate this portion we need to draw arrow like this. So okay, I am drawing with different color. Okay, so we need to draw arrow like this. So this is spring force K1 X1. Okay. Now when I am drawing the spring force at this point, which is the spring force of spring 2. Okay, how I can draw? For that you need to see the displacement of this spring. Now you can see, since it is coming between one M1 and M2, and displacement of M1 is X1, displacement of M2 is X2. So you can say, sir, if X1 is more, can I say displacement of spring 2 will be X1 minus X2, but by that amount spring 2 will compress. Why it will compress? Because if X1 is more, so it is compressing the spring. Na? So displacement, since it is between X1 and X2, spring force is displacement of spring 2 will be X1 minus X2, it will compress. Similarly, if X2 is more as per this direction, and direction is this, then displacement of this spring will be X2 minus X1, but it will elongate. Yes, if X2 is more, it will elongate. Na? But right now we are deriving the equation, so I don't know na, whether X1 is more, X2 is more. It doesn't matter. What you will do now, we will do now, when I am deriving the equation now, either assume X1 is more than X2 or assume X2 is more than X1. It is your will. If you want to assume X1 is more than X2, you can assume that also. If you want to assume X2 is more than X1, you can assume that also. It is your will. Okay. But in final equation, there will be no change. Whether you are taking X1 is greater than X2, okay, whatever final equation you will get, same final equation you will get if you are considering X2 is greater than X1. No change. No change means no change. Okay. And I am assuming X2 is more than X1. Right now I am assuming X2 is more than X1. If you want, you can assume X1 is more than X2 also. Okay. But it doesn't mean while I am deriving the equation, I am assuming X2 is more than X1. Means it doesn't mean this equation is only valid for this case. No. When X1 is more, in that case also that equation is valid. Because if X1 is more, so X2 minus X1 will automatically come with minus sign. Na? X2 minus X1 will automatically come with minus sign. So it is valid for all the cases, whether X1 is more, X2 is more. But while deriving the equation, you had to take any one assumption. So I am taking X2 is more than X1. Now if X2 is more than X1, can I say the displacement of spring 2 will be X2 minus X1 first of all. And by this amount, as per this information, spring 2 will elongate. It might be possible actually spring 2 is contracting. In that case, now automatically X2 minus X1 will come negative because I am assuming it is elongating. So if it is coming negative, means it is contracting. But right now, as per this information, can I say, since it is trying to elongate the spring, na, spring 2. So X2 minus X1 is the displacement of this spring, and by this amount, it is elongated. Now, so due to this, what will be spring force? If the stiffness of this spring is K2, so spring first I am writing the value. K2 in bracket X2 minus X1. Here also I am drawing K2 in bracket X2 minus X1. But it will be tensile or compressive. So right now, since it is elongating, so can I say as per this assumption, spring 2 will be in tension? Yes. Okay, this is also the ability of spring 2, it is also. Since it is in tension, for that at this point, draw such arrow which is trying to elongate this portion. Now to elongate this portion, we need to go like this. So this is the spring force here. Similarly, it is here also we'll draw the spring force of spring 2, na, because it is also spring 2. It is for ability of mass 1. Yes. So draw such arrow which is trying to elongate this portion of the spring. Because I am drawing ability of mass 1, in ability of mass 1, this is spring 2, na. And since it is in tension, so we'll draw such arrow which will try to elongate this portion of spring 2. For that, we need to draw like this. Clear? Now here we need to attach internal force. It is spring 3. Now if this mass M2, it is coming between M2 and fixed end. So it is fixed end. So displacement of this point will always be 0. So whatever is the displacement of mass 2, that will be the displacement of spring 3. And displacement of mass 2 is X2 this side. And as you can see, due to this motion, spring 3 will contract. So can I say displacement of this spring 3 is X2, but by this amount it is contracting. Okay, so by this amount, a displacement of this spring is X2, and by this amount it is contracting. Yes. So what will be spring force? Spring force will be stiffness K3. So K3 X2. First of all, this is the value. Now what about direction? It is contracting, means nature of spring force will be compressive. So for that case, in this point, draw such arrow which is try to contract this portion of spring because it is in compression, and to contract this portion of spring we need to draw arrow like this. I think it should be clear to everyone. So like this you can draw FBD. It is very easy. Okay, just we will do practice one more two time now. I will discuss this with numerical also. You will automatically you can easily draw this this FBD. After that, entire analysis is simple. Okay, only you have to understand something, but most important is drawing this FBD, because if you do mistake in drawing FBD, now your own solution will be incorrect. So I think it should be clear to everyone. Okay, now in FBD of mass 1, what I am doing, since I have involved the inertia force, and after involving inertia force, we know every FBD will be in equilibrium. Equilibrium means in every FBD net force will be 0. So this all forces are coming in x direction. So what I am doing in FBD of mass m1, I am taking summation of force in x direction equal to 0. Okay, summation of force in x direction equal to 0. Okay. Okay, now while using this equation, suppose I am adding this side force and subtracting this side. It is your will. If you want, you can add this side force, then subtract this side. So right now I am adding this side force and subtracting this side. Na? So m1 x1 double dot is this side which I am adding. So it will come with plus sign. So plus m1 x1 double dot. Now k1 x1 is also this side which I am adding. So plus k1 x1. Yes. Now this force is coming this side which I am subtracting. So minus k2 in bracket x2 minus x1. Yes. No other force is coming in FBD of mass 1, and this will be equal to 0. Now I'm just setting this equation. Now how you setting means, first I am writing x1 double dot term. So already x1 double dot term is this m1 x1 double dot. Yes. Now no other double dot term is coming. Now in displacement term now, first I am writing x1 term, then I will write x2 term. Like it will simplify this equation. Now it is plus k1 x1. It will be minus k2 x2. This minus plus k2 x1 equal to 0. So first write x1 double dot term. So m1 x1 double dot. After that, now if x2 double dot term is also coming, so then I will write that term also. But right now here x2 double dot term is not coming. After now displacement term, in displacement term first write x1 terms. So this is k1 x1, this is plus k2 x1. Okay, so can I say it will be k1 plus k2 into x1? After that write x2 term. So in x2 term only this is coming. So it is minus k2 x2 equal to 0. Suppose this is equation 1. Like this, set in standard form. Okay. Similarly, now we will draw the FBD of mass m2. Yes, FBD of mass m2. So again that FBD also I am taking summation of force in x direction 0 because I have involved inertia force. Okay, and in this equation, suppose I am adding this side force, then subtract this side force. So m2 x2 double dot already coming in this direction which I am adding. So it will come with plus sign. So plus m2 x2 double dot. Then this force k2 in bracket x2 minus x1 coming this side which I am adding. So it will be plus k2 in bracket x2 minus x1 plus this is k3 x2 this side which I am adding. So plus k3 x2. That is equal to 0. It will be, again I am writing first x1 double dot term. So no x1 double dot term is coming. So don't need not to write. Okay, now x2 double dot term. So this term is coming now m2 x2 double dot term. Now in displacement, first write x1 term. Okay. I'm expanding this. So it is k2 x2 minus k2 x1. If I'm doing any calculation error, press correct me. Plus k3 x2. Now I think it's correct. K2 x2 plus minus k2 x1 plus k3 x2. Yes, it's correct. So x1 double dot is not coming. Now x2 double dot is coming. So it is m2 x2 double dot. Now x1 term, this is x1 term. So minus k2 x1. Now x2 term. So x2 term is plus k2 x2 plus k3 x2. So x2 will come common. So it will be k2 plus k3 into x2. This is equal to 0. Suppose this is equation 2. So like this, you can derive the equation of differential equation of vibration. This is for mass 1. This is for mass 2. I think it should be clear to everyone. This we got from the video of mass 2. Yes. Now, since here two independent equation is coming now, okay, and ultimately you can see two parameter is coming, like in displacement x1 x2 is coming, in acceleration x1 double dot x2 double dot term is coming. So what I can do now, I can write these terms in a matrix. Okay, so you can write this differential equation in matrix form also, and sometimes it might be possible examiner can ask differential equation in matrix form. How? See, in matrix form, how I will write now? See, if you say take any general case of spring mass system in 1 degree of freedom system now, for that case we know this is the equation of vibration mx double dot plus kx equal to 0. Yes. If we are writing in matrix form now, okay, and I'm writing for 2 degree of freedom system. So what will happen now? I will write the mass matrix into double dot term plus stiffness matrix. How you can write that I will explain, don't worry, into displacement term. Now here I am writing acceleration terms and here I am writing displacement term. Okay, so in displacement x1 x2 is coming, so in acceleration x1 double dot x2 double dot will come. So this matrix will be 1 order 2, means here x1 double dot, just try to understand, x2 double dot. Similarly here x1 will come and here x2 will come. Okay, now coefficient of this double dot, it will be mass matrix. In the coefficient of displacement, it will be stiffness matrix. Try to understand now. Now this mass matrix and stiffness matrix is of 2 by 2 order, means here 4 element will come. Now you can think why here 4 element is coming. Similarly, stiffness matrix is also it is of matrix of 2 by 2 order, means again here also 4 element will come. And you can easily understand why 4 element will come. So see, why 4 element? See, see, this first 2 element represents, this element is representing the coefficient of x1 double dot, which we are getting from this first equation. First equation means FBD of mass 1. Similarly, it is representing the coefficient of x2 double dot, which we are getting from first equation. Similarly, this will represent the coefficient of x1 double dot, which we are getting from second equation. This element will represent the coefficient of x2 double dot, which we are getting from second equation. Okay. Okay. Similarly, what is this term? It is representing the coefficient of x1, which we are getting from first equation. This element is representing the coefficient of x2, which we are getting from first equation. Similarly, this element is representing the coefficient of x1, which we are getting from second equation. This element is representing the coefficient of x2, which we are getting from second equation. So this first 2 element will get from first equation. This second 2, last 2 element, this 2 will get from second equation. One is the coefficient of one term, here 1 double dot, here displacement coming. Second is the coefficient of second term. Yeah, means coefficient of x2 double dot here. Sorry, second equation, second. Okay, and here we are getting from second equation, from the coefficient of displacement. Here I am explaining once again. See, in first equation, the coefficient of x1 double dot is m1. So this element will be m1. Now this is the coefficient of x2 double dot from first equation. So in first equation, x2 double dot term is not coming. So it will be 0. Now go to second equation. This is second equation. Now the coefficient of x1 double dot, here x1 double dot is not coming, means coefficient of x1 double dot is 0. So this term is 2. Now this is the coefficient of x2 double dot in second equation. So in second equation, this is x2 double dot whose coefficient is m2. So this is m2. Like this you can write. I think it should be clear to everyone. I will discuss with one more practice question also. Like here, in first equation, it is the coefficient of x1, it is the coefficient of x2. So in first equation, the coefficient of x1 is k1 plus k2. So this will be k1 plus k2. Yes. Now, in first equation, the coefficient of x2 is minus k2. So this is minus k2. Now in second equation, this is the coefficient of x1, it is the coefficient of x2. So in second equation, coefficient of x1 is minus k2. So this is minus k2. Now in second equation, the coefficient of x2 is k2 plus k3. So this is k2 plus k3. So like this you can write. So this is differential equation in terms of matrix for 2 degree of freedom system. Clear? It is the total elongation for which you are asking. It is the total elongation of spring 2 na, x2 minus x1. If it is contracting, automatically it will come with minus 1. So like this you can write this matrix. I think it should be clear to everyone how I have written this equation. Okay, again I'm explaining here x1 double dot, x2 double dot, x1 x2. Now now coefficient of double dot is mass, so it is mass matrix. Coefficient of displacement is stiffness, so it is stiffness matrix. Now stiffness matrix will be 2 by 2 order. This element is representing the coefficient of x1 double dot in first equation, x2 double dot coefficient in first equation. It is the coefficient of x1 double dot in second equation, coefficient of x2 double dot in second equation. So right now in first equation, coefficient of x1 double dot is m1 and x2 double dot is not coming, so coefficient of x2 double dot is 0. So coefficient of x1 double dot is m1, coefficient of x2 double dot is 0. Now in second equation, x1 double dot is not coming, so coefficient of x1 double dot is 0 and coefficient of x2 double dot is m2. Coefficient of x1 double dot is 0, coefficient of x2 double dot is m2. Very simple. Similarly here, it is representing the coefficient of x1 in first equation and coefficient of x2 in first equation. So you can see in first equation coefficient of x1 is k1 plus k2, that's why here k1 plus k2. Coefficient of x2 is minus k2, that's why here minus k2. Now it is the coefficient of x1 in second equation and coefficient of x2 in second equation. So in second equation coefficient of x1 is minus k2, in second equation coefficient of x2 is k2 plus k3. So like this you can write. Okay, clear? Yes. Now what is the meaning of a static and dynamic coupling? So see how x1 and x2 are relating each other. If they are relating each other due to the masses, okay, and mass will come in inertia force, so that is known as dynamic coupling. If they are interrelated with each other due to the stiffness part, so that is known as a static coupling, because stiffness is elastic force, elastic force. Okay, so it is known as static coupling. Okay, and if it is relating with each other due to both mass terms and stiffness term, then it is combination of static and dynamic couplings. Okay, but how we can identify that? So see, for that now in this differential equation which you are getting in matrix form, see this off diagonal term, this is off diagonal term, this is off diagonal term. Now try to understand, if off diagonal term in mass matrix is 0 na, means there is no dynamic coupling, and if it is non-zero, means they are linked, x1 and x2 are linked due to dynamic coupling. Okay, so you have to see this off diagonal term is 0, means no dynamic coupling. If it is not 0, it is dynamic coupling. Similarly in stiffness matrix, if off diagonal term matrix element is 0, suppose if it is 0, so there is no static coupling, and if it is non-zero, it is having static coupling. Clear? Now suppose in both the term na, if off diagonal term are 0, here also, means in that case we are getting neither static coupling nor dynamic coupling. But suppose in some question it is non-zero but it is 0, means we are getting dynamic coupling but not static coupling. It is 0 and it is non-zero, means we are getting static coupling. But it is also non-zero, it is also non-zero, means that is combination of static and dynamic coupling. Okay, I am not going in detail because in 2 hours I have to complete this entire topic. So I am discussing the only these things which is important for GATE examination. Okay, okay, in paired batches I will go discuss these things in very detailed manner, but for GATE exam this discussion is sufficient. Okay, summary is if in mass matrix off diagonal term is 0, means no dynamic coupling. If it is non-zero, it is dynamic coupling. In stiffness matrix, if non-diagonal term is 0, means no static coupling. If it is non-zero, it is having static coupling. So what I am trying to say, if this term is 0, means no dynamic coupling. If it is non-zero, it is having dynamic coupling. Similarly, here in stiffness matrix, if this non-diagonal term is 0, it is having no static coupling. If it is non-zero, means we are getting static coupling. Like suppose if same question is coming in examination and examiner will ask they are related with static coupling or dynamic coupling, so what will be answer? What will be the answer? Sir, static coupling. Why? Because in stiffness matrix, non-diagonal term is non-zero. So for this question, the answer will be static. So this is about coupling. But next important discussion is how we can calculate natural frequency. In 2 degree of freedom system, we'll get 2 natural frequencies. Same diagram I drawn. So what we'll do now? First of all, we'll find these equations. Okay, which I already found. Nah? And after finding this equation, if you want, you can write this matrix. Okay, through this matrix also you can find natural frequency. Okay, so for this question I have already found. If you write the this matrix now, for this question I am getting like this now: m1 0 0 m2. This discussion I have already done. x1 double dot x2 double dot plus here it is k1 plus k2 minus k2 minus k2 k2 plus k3 x1 x2 equal to 0. Okay, yes, if we simplify this now, ultimately you will get this two equation, like first row first column, it is m1 x1 double dot plus 0 x2 double dot means 0 plus k1 plus k2 x1 minus k2 x2 equal to 0. This is first equation. Similarly, second equation, 0 x1 double dot means 0 plus m2 x2 double dot minus k2 x1 plus k2 plus k3 x2 equal to 0. That is second equation. But I have written this equation in terms of matrix. Okay. Now my objective is to calculate natural frequency, and since it is 2 degree of freedom system, now I will get 2 natural frequency. But how? Okay. So right now, suppose, okay, natural frequency of this system is omega. Okay, whether it is first natural frequency or second. Right now, but I am assuming it is vibrating with one natural frequency, which is omega. Or if you want to write omega n, you can write. It is your way. Okay. So right now it is vibrating with natural frequency omega n. Okay. Yes. So if it is vibrating with natural frequency omega n, what will be the equation of x1 and what will be the equation of x2? So see, this we already studied in single degree of freedom system also, that whenever any mass is vibrating with natural frequency omega n, then the equation of displacement will always be in this form. X is equal to capital X is amplitude, sine omega n t plus phi. Okay, where omega n is the natural frequency and phi is the phase angle and capital X is the amplitude. Okay, similarly, can I say that what can be the equation of x1? Suppose for x1 is the displacement of mass 1, amplitude is capital X1. So can I say when it is vibrating with natural frequency omega, an equation of x1 will be capital X1 sine omega n t plus phi 1. Suppose for mass 1 I am taking amplitude capital X1 and phase angle phi 1. But when this equation will get when it is vibrating with natural frequency omega n. Similarly, what will be the equation of x2? It will be capital X2 sine omega n t plus phi 2, because I am assuming both the mass is vibrating with same natural frequency, which is omega n. And if it is vibrating with this equation, frequency, the displacement of mass 1, that is x1, will be like this, and equation of x2 will be like this. Yes. Now I had my objective is to find the value of omega n. My objective is to find the value of omega n. Automatically I will get 2 value of omega n. So see, I am putting here, but here x1 x2 is coming, but here x1 double dot x1 double dot x2 double dot is coming. So I am finding the expression of x1 double dot and x2 double dot also. So what will be the expression of x1 double dot? Try to understand. Differentiate this equation 2 times with respect to time. So see, if I will differentiate with respect to time 1 time, it will be x1 capital X1. Differentiation of sine is cos, so it will be cos omega n t plus phi. But when we are differentiating with respect to time, when we are differentiating for doing differentiation for sine, this coefficient of time, which is omega 1, will come outside. So can I say if I will differentiate this with respect to time 1 time, okay, so we will get capital X1 omega n cos omega n t plus phi. But this is the differentiation with respect to time 1 time. But we have to differentiate with 2 times. So again, I have to differentiate d by dt. Now see, differentiation of cos is minus sign. So it will become minus sign. and again 1 omega 1 will come outside, so it will become minus x1 omega n square. 1 omega n again came outside, so omega n square, and why minus? Because differentiation of cos is minus sine, so minus sine omega nt plus 1. Similarly, if you write the equation of x2 double dot, can I say it will be minus x2 omega n square sine omega nt plus phi 2, because only difference is instead of capital X1, capital X2 is coming, instead of phi 1, phi 2 is coming. So the pattern will be same, na? Yes. So just put this in this matrix. It will be M1 0 M2 0 M2 x1 double dot. X1 double dot is minus capital X1 omega n square sine omega nt plus phi 1, and x2 double dot is minus x2 omega n square sine omega nt plus phi. Plus. At last I will make the summary, don't worry. Plus it is k1 plus k2 minus k2 minus k2 k2 plus k3. It is x1, which is capital X1 sine omega nt plus phi 1, and it is capital X2 sine omega nt plus phi 2, that is equal to 0. Now what will happen? M1 0 0 M2. See, can I say I can take this sine omega nt plus phi 1, sine omega nt plus phi 2 coming this side also, sine omega nt plus phi 1 and sine omega nt plus phi 2 coming this side also. So I can take this part common, and common part will come this side, not it will become 0. So when you in actual exam, if you are writing this equation, you need not to write this, because this part will get cancelled. So ultimately it will be minus capital X1 omega n square minus capital X2 omega n square. But next time when I will write in exam, I will directly avoid this part during writing. Okay. So okay, now similarly it will be k1 plus k2 minus k2 minus k2 k2 plus k3. So if I am not writing this sign part, it will be capital X1 capital X2, that is equal to 0. Now see, if I will shift this minus omega n square inside this side, so, I will multiply this minus omega n square with this side. So here capital X1 X2 will come remain, and here also capital X1 capital X2 is remaining. Okay, so it will become now, try to understand, minus M1 omega n square. I am only multiplying with term apart from X1 and X2. Now 0 into M1 into this. Now 0 into this, but don't include X2. So 0 into minus omega n square, ultimately it will be 0. Yes. Now 0 into minus omega n square, so it will be 0. M2 into minus omega n square, so it will be minus M2 omega n square. What I am trying to explain and try to understand that. Now only write capital X1 capital plus. It is k1 plus k2 minus k2 minus k2 k2 plus k3 capital X1 capital X2 equal to 0. So ultimately, can I say it will become, see, capital X1 capital X2 is common, na? So it will be minus M1 omega n square plus k1 plus k2. So minus M1 omega n square plus k1 plus k2. Similar this 0 plus minus k2, so minus k2, 0 plus minus k2, so minus k2, minus M2 omega n square, okay, plus k2 plus k3. Capital X1 capital X equal to 0. Yes. Now in a linear algebra, if you studied mathematics, how to find the value, solve this equation you have studied. When it will be 0 na, if you want non-trivial solution. So when it will be 0 na, when determinant of this part is 0. Determinant of this part is 0. So what I can do now to find natural frequency. What now final equation which I am writing here now is known as frequency equation, because this equation I will use to calculate natural frequency. Okay, I'm just following the step because since it is not paid based, so I'm not going in too much detail. Just try to understand the step. When this will be 0 now, when determinant of this part is 0. Okay, determinant of this part is 0. Okay, this is known as frequency equation. So it is minus m1 omega n square plus k1 plus k2, yes, minus k2 minus k2 minus m2 omega n square plus k2 plus k3, and determinant of this 0, and equate this with 0 now, you will get 2 natural value of omega n. That is nothing but 2 natural frequency of this vibratory system. Okay, automatically when you will solve the numerical, I will solve. Yes, but now you can say, sir, it is very time consuming process. So it is looking like time consuming now, but when you will practice 2 to 3 more questions now, you will feel that it is not much time consuming, but you have to only remember some steps. Like now, see, first of all, derive this equation. This equation you have to derive. There is no shortcut, because if I will discuss the shortcut of this, you will do mistake. So if you don't want to do mistake, first derive this equation. Now after that, now you can directly write this equation if you try to understand the step. How? See, when you will get, if x1 is capital X1 sine omega n t plus phi. Okay, now if you do differentiate that term with respect to time two times now, definitely sine omega n t plus phi is coming. So if you differentiate with respect to time one time, it will be omega and cos omega n t plus phi. Again if you differentiate, it will be minus omega n square sine omega n t plus phi. So ultimately it will be capital minus capital X1 omega n square. So I am keeping capital X1 here, shifting minus omega n here, this side. So it will become minus m1 omega n square. See, try to understand. Minus omega n omega m1 omega n square. Here it is 0. So 0. First see the term which I am getting from this side. Similarly, if you will differentiate x2 double dot x2 equation with respect to time 2 time now, you will get minus x2 omega n square. Understand the pattern. So I am keeping x2 this side. Okay, and minus omega n square I am multiplying with this two terms. So it will be 0 into minus omega n square means 0, and it is m2 into minus omega n square means minus m2 omega n square. Try to understand. Now from this part. So already now if x1 is capital X1 sine omega n t plus phi, x2 is capital X2. So already x1 x2 is coming. Sine part we need not to write. Okay, because that will cancel. Okay. So already directly write this. So it is k1 plus k2. Okay, so plus k1 plus k2 minus k2. So minus k2 here. This is minus k2. So minus k2. Then k2 plus k3. So that's why k2 plus k3. Try to understand. If you will practice 1 or 2 question, you will you can directly write this. Even if you are getting confused now, then what you can do for differentiate x1 with respect to time 2 times, x2 with respect to time 2 times, put here, but don't write sine terms. Don't write sine term. Then shift this part this side. Ultimately, finally, you will get this equation. And when you want to find natural frequency, now just ensure one thing: determinant of this will be 0, which is known as frequency. Now after that, it is mathematics. Now, okay, from this you will get 2 value of omega n. Okay. Like if I want to find the determinant of this, what is the method? Determinant of this will be multiplication of these two terms minus multiplication of these two terms. This is the method to find determinant of 2 by 2 order matrix. If I want to find the determinant of this, it will be AD minus BC. So same formula I am applying. So multiplication of these two terms. So it is minus m1 omega n square plus k1 plus k2. Okay. Minus m2 omega n square plus, actually it was k3 na, plus k2 plus k3 minus multiplication of this term, two terms. So minus minus will be plus, it will be k2 square. This minus is already coming. So k2 square equal to 0. Now from this equation you will get two value of natural frequency. Okay. But now if question is coming now, this solving this equation is very lengthy. So if same question is coming in examination, either examiner will give the numerical value of k1, k2, k3, m or m2, or there will be some relation like k1 is equal to k, k2 is 2k, k3 is k, m1 is m, m2 is 2m. Like this, examiner will give information. So when I am explaining now how to solve this equation, for that I am taking a case. Say I am taking a case 1 in which examiner has given, suppose k1 is equal to k2 equal to k3 equal to k, and say m1 is equal to m2 equal to m. That will be given in the exam, don't worry. Right now suppose examiner has given question in which k1 equal to k2 equal to k3 equal to k, m1 equal to m2 equal to m. Just to explain how you can solve this equation, because in terms of k1, k2, k3, m1, m2, it is very lengthy. So I am doing simplification of this. So we put here now, it will become minus m omega n square plus k1 plus k2, but k1 is k, k2 is also k, so it will be 2k into minus m omega n square plus k2 plus k3, but k2 is also k, k3 is also k, so it will be plus 2k minus k2 square, and k2 is k, so minus k square. This is equal to 0. Now solving this equation is simple. Now just expand this. It will be minus m omega n square and minus m omega n square. So minus minus will be plus. So it will be m omega square. M into m is m square. Omega n square into omega n square means it will be omega n to the power 4. Yes, good. Now ultimately minus m omega n square into plus 2k. So minus plus is minus. Can I say it will be 2km omega n square? Yes. Now I'm multiplying 2k with this two terms. So first I'm multiplying 2k with this term. So it will be plus minus minus 2km omega n square. If I'm doing calculation error, please correct me. Plus 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 4k square minus k square equal to 0. Now just simplify this. So it will be m square omega n square minus 2km omega n square minus 2km omega n square. So minus, both will add up because both will coming minus sign. So it will be minus 4km omega n square plus 4k square minus k square means it will be plus 3k square equal to 0. Now to solve this equation, sorry, it is omega n to the power 4. What I am doing, you can see here omega n term is not coming, here omega n square is coming, and can I say here omega n square is coming, because omega n to the power 4 you can also write like this now, omega n square then again square. So what I am doing now to solve this equation and from this to find the value of natural frequency omega, what I am assuming, omega n square equal to lambda. And if I assume omega n square equal to lambda, now this equation will become m square lambda square minus 4k m lambda plus 3k square equal to 0. And from this equation our objective is to find the value of lambda. So you can see it is double order polynomial na? And if equation is coming like this, ax square plus bx plus c equal to 0. So what is the method to find the value of x? It is minus b plus minus root over b square minus 4ac divided by twice of a. If you want, you can directly use this formula to calculate the value of lambda. So I'm using this. So minus b, b is the coefficient of x means here coefficient of lambda, a is this coefficient of lambda square, and c is this constant part. So if I will use this minus b, so coefficient of lambda is minus 4km na? So minus of minus 4km plus minus root over b square means minus 4km whole square minus 4ac. A is the coefficient of lambda square which is m square, c is this constant term which is 3k square divided by twice of a means twice of m square. So lambda will be minus minus plus 4km plus minus. See, right now separate numerical digit, but you can see now, if you see k and m term, here k square m square is coming, means you can say km whole square is coming. Now it is m square, it is k square, so here also k square m square is coming. So from this inside root, can I take k square m square common? Means km whole square common, and it will bring km whole square outside root, it will be become km. This is square, because square root of km whole square will be km, na? So I have brought this km part outside root, means from inside I had taken k square m square outside. Okay, so now write the term apart from k square m square. So here minus 4 whole square. First of all, square of minus will be plus, and 4 4 is 16, so it will be 16 k square m square, which I already taken outside, minus 4 into 3 12, and k square m square already I had taken common, divide by 2m. Yes, so it will be lambda equal to km, I am taking common, divided by 2m square. Inside it will be 4 plus minus 16 minus 12 is 4, and square root of 4 is 2. So you'll get one value of lambda after taking plus sign. So it will take plus sign, 4 plus 2, or first I am writing that value lambda, which I will get by taking minus sign. You'll understand why I am writing this first. It is your value, you can write anything first. So 4 minus 2 is 2, divided by 2. So 1 will remain, mm will get, 1 m will get cancelled, so it will be ultimately k by m. It will take plus side, 4 plus 2 6, 6 divided by 2 is 3, so it will be 3k by m. So by taking plus sign, we are getting 3k by m. Now lambda is nothing but omega n square. So can I say, if you will do square root, you will get two value of omega n. So first value will be square root of this, which is root k by m, and second will be square root of this, which is root 3k by m. Now out of this is the two natural frequency, but out of these two value, whichever value is lesser, right now it is lesser, and definitely lesser value we will get by taking minus, and that's why I written this first. That is known as first natural frequency. So here this term I am denoting as omega n, which is first natural frequency. So if the examiner is asking now what is the first natural frequency of this system, means examiner is talking about this. Okay, similarly this is nothing but the value which is getting more is second natural frequency. It is second natural frequency. So examiner asking both the natural frequency, one is root k by m for this question, when k1 is equal to k2 equal to k3 equal to k, m1 equal to m2 equal to m, and second is 3 root 3k by m. So like this you can find the two natural frequency. I think it should be clear to everyone. If I will discuss this with one question, you will easily understand. Okay, but it should be clear to everyone. Okay, so I am discussing with some questions. Okay, in this question our objective is to find natural frequency, like what this question is saying now. Consider the spring mass system shown in figure. Okay, if we have mugged this relation now, but how, this is very lengthy, how I can mug. Okay, if we mug this relation, so just see what is the value of m1 m2 k1 k2 k3, just put in that equation, but we are not mugging that equation. That's why again I will derive the equation. Okay, but I have only told you to remember one thing, that na, if you got this equation, so how you can directly write this, I explained. Again I am explaining how you can write. See, if x1 is capital X1 sin omega n t plus phi, and x2 is capital X2 sin omega n t plus phi 2, so x1, if you will calculate x1 double dot, here minus capital X1 omega n square will come, sin term will get common, so here you need not to write sin term. Similarly in x2 double dot, minus x2 omega n square will come. Okay, so if we'll bring this minus omega n square this side, so it will be minus m1 into minus omega n square, means minus mn omega n square. Okay, in terms of displacement I writing, it is 0 into minus omega n square, that's why 0 first. Okay, it is 0 into minus omega n square, that's why 0, and it is m2 into minus omega n square, means minus m2 omega n square, like this. Okay, and apart from this, separately capital X1 x2 is coming. Similarly here already x1 x2 is coming, so if you replace x1 by capital X1 sin omega n t, it will be capital X2 sin omega n t. Sin part will get cancelled, so it will be capital X1 x2, which I already written here. So in this part I need not to change anything, it is k1 plus k2, so directly write k1 plus k2. Yes, it is minus k2, so directly write minus k2. It is minus k2, so again directly writing minus k2. It is k2 plus k3, so plus k2 plus k3. I have combined both the term now. when I written in terms of capital X1, capital X2. Clear? Yes. Now, when this will be 0, when determinant of this part is 0. So now do determinant of this part is 0. Okay. Okay. You will get this equation. Assume omega n square equal to lambda. After that assumption, automatically you will get 2-order polynomial. Find the root of that equation. You will get 2 value of lambda, which is omega n square. So square root of that, you will get 2 value of omega n. The value which is lesser is known as first natural frequency. The value which is more is known as second natural frequency. Clear? Yes. I am explaining with questions like this question. Now, but in first part, now exam asking whether it is static or dynamic or both or no coupling. So that I already explained. If you are having the equation of this vibration, differential equation of this vibration, and writing in terms of matrix form. So in mass matrix of diagonal term is 0, means no dynamic coupling. If it is non-zero, means dynamic coupling. If in stiffness matrix non-diagonal term is 0, means no static coupling. If it is non-zero, means having static coupling. So when you will derive the equation, you will automatically able to conclude the answer of this question. But here, most importantly, we had to calculate the two natural frequency of this system. That is the main point of discussion. So I am drawing this diagram separately. Just 1 second. Don't think I am rubbing the question. I had just copied the slide. Na? Question is already there. Now, first of all, it is 2-degree of freedom system because we need to tell the displacement of this mass also, this mass also. Okay. So suppose the displacement of this mass from mean position I am representing as x1, already written here, and displacement of this mass from mean position I am representing as x2. So now deriving the equation of vibration. Okay. Okay. For that I am assuming right now x2 is more than x1. It is just assumption. Okay. So suppose this is mass 1. This is mass 2. So if here I am drawing the body of mass 1, this mass is m, displacement is x1 toward this side. Here this is spring is attached. This is spring 1, whose stiffness is k. Suppose this is spring 2, spring 1, spring 2. The stiffness of spring 2 is also k. So here internal force will come, here internal force. Similarly, a body of this mass is a body of mass 2. This mass is first of all 3m, na? See the value correctly. Here this is spring 2 is attached, cutting here, whose stiffness is k. This is spring 2. This is suppose spring 3, whose stiffness is again k. Cutting, I am cutting from this location. Clear? Now see, and the displacement of this mass from mean position is x2. Now, first of all, spring, I am involving inertia force. So mass of this is m, not m1, it is m, na? Yes. And displacement is x1, so acceleration will be x1 double dot. So can I say inertia force will be m x1 double dot? Direction will be opposite to x1 double dot. If x1 is this side, x1 double dot will also be this side. So inertia force will be opposite to this, means it will be this side. Okay. So the inertia force of this mass is 3m. Its displacement is x2, so acceleration will be x2 double dot. So inertia force will be 3m x2 double dot. Direction will be opposite to x2 double dot. x2 is this side, so x2 double dot will also be this side. So inertia force will be opposite to this, means this side. Next is spring force. So in spring force, in a body of spring 1, see, spring 1 is attached between fixed and this mass 1. Okay. So displacement of this point is 0, displacement of this point is x1. So can I say displacement of spring 1 will be x1, and if this mass is going this side, spring 1 will elongate. So can I say displacement of spring 1 is x1, and by this amount it is elongating. So in spring 1 body, spring force will be k x1. I am writing with green color, na? K x1. Now direction. So since it is elongating, so it will be in tension. So draw such arrow at this point which will try to elongate this portion. For that I need to draw arrow like this. So this is the spring force at this instant in the body of spring 1. Okay. In a body of mass 1 at spring 1. Okay. Now here See, if I am assuming x2 is more than x1, so displacement of spring 2 will be x2 minus x1, and this displacement dominating the, so ultimately spring 2 will elongate, because due to this motion spring 2 will elongate. If you are assuming x2 is more than x1, so can I say displacement of spring 2 is x2 minus x1, and by this amount spring 2 is elongating. Okay, so can I say spring force in spring 2 FBD will be K in bracket x2 minus x1, and it is tensile nature because it is elongating. So I am showing the spring force here. Okay, so it is first of all K in bracket x2 minus x1, and it is tensile because it is elongating. So for that, at this point draw such arrow which will try to elongate this portion. For that I need to draw arrow like this. Similarly, this is also spring 2. So here also force will be K in bracket x2 minus x1. But what about direction? Draw such arrow which will try to elongate this portion because it is elongating. Na? For that I need to draw arrow like this. Okay, so don't be in a hurry. Na? Draw arrow correctly. Now spring 3. This is the FBD of spring 3. See, stiffness of spring 3 is K. It is between fixed and x2. So displacement of spring 3 will be equal to x2 na, because displacement of this point is 0. But when this mass is going in this side x2, in this direction, spring 3 will compress. So can I say here displacement of spring 3 is x2, but by this amount it is compressing. Yes. So in spring force in the FBD of spring 3, definitely it will be stiffness is K, displacement is x3, so K x3. But what about direction? Since it is compressing, so draw such arrow at this point which will try to compress this portion. And to compress this portion, I need to draw arrow like this. Yes. So now FBD is completed. So now what I am doing, FBD in FBD of mass 1, in FBD of mass 1, use summation of force in x direction equal to 0. And while using this, suppose I am adding this side force and subtracting this side. So m x1 double dot already coming this side. So it will be plus m x1 double dot. K x1 is coming this side which I am adding. So plus k x1. This k x2 x minus x1 coming this side which I am subtracting. So it will be minus k in bracket x2 minus x1. Just set this equal to 0. So m x1 double dot plus k x1 minus k x2 minus minus plus k x1 equal to 0. First write x1 double dot m x1 double dot, then x2 double dot, but now x2 double dot term is coming, then x1, so k x1 plus k x1, so 2k x1, then x2, so minus k x2 equal to 0. This is equation. Clear? Similarly, in FBD of mass 2, use summation of force in x direction equal to 0. Again, while using this, suppose I am adding this side force, subtracting this side force. So 3m x2 double dot already this side which I am adding. So plus 3m x2 double dot. Now this is spring force k in bracket x2 minus x1. This side which again I am adding. So plus k in bracket x2 minus x1. Then this is spring force k x2 this side which I am adding. So again plus k x2. Now just simplify this equation equal to 0. So it is 3m x2 double dot plus kx2 minus kx1 plus kx2 equal to 0. Now x1 double dot is term is not coming, then x2 double dot, this term is coming, 3m x2 double dot. Now x1 term, so you can see already in x1 term minus kx1 is coming, so minus kx1. Now x2 term, in x2 term plus kx2 means it is 2kx2. Check the calculation, if you are doing calculation error, plus correct me. So plus 2kx2 will come. Clear? This is equal to 0. So this is equation 2. Okay. Now just write in terms of matrix. It is mass matrix into x1 double dot x2 double dot plus stiffness matrix into x1 x2 equal to 0. Now, so this is the coefficient of x1 double dot in equation 1 and coefficient of x2 double dot in equation 1. So in equation 1, the coefficient of x1 double dot is m and no x2 double dot is coming, so coefficient of x2 double dot is 0. So coefficient of x1 double dot is m and coefficient of x2 double dot is 0. Similarly, it is the coefficient of x1 double dot in equation 2 and it is the coefficient of x2 double dot in equation 2. So in coefficient equation 2, x1 double dot is not coming, so this is 0. And the coefficient of x2 double dot is 3m, so this term is 3. Similarly, in stiffness matrix, first two element. It is representing the coefficient of x1 in equation 1 and it is coefficient of x2 in equation 1. So in equation 1, coefficient of x1 is 2k and coefficient of x2 is minus k. It is 2k and it is minus k. Similarly, this is the coefficient of x1 in equation 2 and this is the coefficient of x2 in equation 2. So in equation 2, coefficient of x1 is minus k, so this is minus k, and coefficient of x2 is 2k, so this is 2k. That is equal to 0. Now after that, now I already explained how you can write this equation directly. Okay. That I already explained this equation. How? See, if we are assuming now x1 is capital X1 sin omega n t. So from that, if you will find x1 double dot, you will get minus capital X1 omega n square sin omega n t plus 5. But you need not to write sin omega n t plus 5. So it will be minus x1 omega n square. It is minus capital X2 omega n square. And if we bring minus omega n square inside now, it will be minus m omega n square. 0 into means with this entire term multiply minus omega n square. I am keeping capital X1, capital X2 this side. 0 into minus omega n square is 0. 0 minus 3m omega n square. So it will be capital X1, capital X2. In terms of amplitude, I am writing now. Plus here x1 is capital X1 sin omega n t or 3 plus pi, x2 is capital X2 sin omega n t. Sin term we are not writing. So here directly capital X1, X2 will come. So you need not to change here. Means ultimately step is both side if you are trying to bring capital X1, X2 now. So here I need not to change anything and here I need to multiply with each term minus omega n square. If you want, you can remember this step also. So ultimately it will become minus m omega n square plus 2k. 0 minus k means minus k. 0 minus k means minus k. Minus 3m omega n square plus 2k into, it is matrix multiplication na, capital X1, capital X2 equal to, this is in terms of amplitude na. Now when it will be 0, so for that now write frequency equation. So determinant of this part minus m omega n square plus 2k minus k minus 3m omega n square plus 2k, and determinant of this will be 0. From this, by finding this determinant, you will get double order polynomial. From that you will get 2 value of omega n, that is nothing but 2 natural frequency, which we have to find. Okay. So see, now determinant of this will be multiplication of these two minus multiplication of these two. So it will be minus m omega n square plus 2k into minus 3m omega n square plus 2k minus multiplication of these two. So minus into minus is plus, k into k is k square. So k square. Already this minus is coming now because multiplication of these two minus multiplication of these two, that is equal to 0. Now just expand this. So first of all, minus into minus, this will be plus 3m square omega n to the power 4. Then minus into plus minus 2km omega n square plus into minus minus 3 to just 6 km omega n square and plus into plus 2k 2 to just 4 na, so 4k square minus k square equal to 0. Now simplify this, and what I am assuming, omega n square equal to lambda. So I am replacing omega n square by lambda. So ultimately it will be 3m square omega n square whole square, and omega n square is lambda, so it will be lambda square minus, first of all, 2 minus 2 km minus 6 km, so it will be minus 8 km omega n square, and I am replacing omega n square by lambda, plus 4k square minus k square means plus 3k square. You can check the calculation. So finally we will get this equation. Again I am writing 3m square lambda square minus 8 km lambda plus 3k square equal to 0. From this we'll get two value of lambda. So just use the formula minus b. So minus of this minus 8km. So minus minus will be plus na. Plus minus root over b square. B square means minus 8km whole square minus 4ac. So 4 m is coefficient of lambda square which is 3m square. C is this constant term which is 3k square upon twice of a. So it will be twice of 3m square means 6m square. Now see here also k square m square means km whole square is coming. Here also m square and k square means km whole square is coming. So I am taking km whole square common and it will bring outside root, it will become km. This minus minus plus 8 km and I am bringing km outside. It means from inside I already taken k square m square common. So now write the values apart from k square m square. So it will be minus 8 whole square. First of all minus square is plus and 8 8 is 64. Minus k square m square already taken common. It will be 4 3 is 12, 12 3 is first of all this minus 4 3 is 12, 12 3 is 36. You can check the calculation. K square m square which I have taken already common and 3 2 is 6m square. Okay, so lambda is coming. Km you can bring common na. So km divided by 6m square ultimately it will be 8 plus minus. Now 64 minus 36 is 28. Now calculation is your part. Now I am not going to discuss the calculation. 64 minus 36. 64 minus 36 is 28. And 28 you can also write. It is root 28. Na? And root 28 I can write like this 7 into 4. And root 4 is 2. So can I say it will be 2 root 7? Why I am not calculating in points now? Because in option is given like this. In terms of root 7 like this in option is given. Na? So it will be 2 root 7. So lambda will be first of all 1m will get cancelled. So it is k by m. Okay. And you can bring directly 2 common and 2 divided by 6 will be 1 by 3. So it will be k by 3m. You can check calculation. I taken 2 common. So 2 here 4 will remain plus minus root 4. And 2 divided by 6 will be 1 by 3. Na? But this is lambda square, that is omega n square. So can I say omega n will be square root of this, and square root of this means it is square root of 4 plus minus root 7 upon 3 into k by 3. By taking minus sign we'll get first natural frequency, and by taking plus sign we'll get second natural frequency. Okay. So this is omega n. The option is given like this, na. Omega n is 4 plus minus root 7 by 3 root over k by m. We matching with which option? So if examiner asking two natural frequency for this question, this is the answer. Apart from this, examiner was also asking whether it is static coupling, dynamic coupling, or both coupling or no coupling. So see, in this matrix form, if you see differential equation now, here off diagonal term is 0. So can I say here no dynamic coupling? But in stiffness matrix, non-diagonal term is non-zero. Means can I say it is having a static coupling, but no dynamic coupling? It's already only having static coupling. And static coupling means which option is correct? Option A. Clear? So here I explained how to calculate natural frequency. Just for understanding, I am discussing one more question. Okay. I am just giving 1 minute or 30 seconds. First try by yourself also, na. This is already GATE Aerospace PYQ. In this question also, our objective is to find two natural frequency of the system. This is the simplest form. Mass m1, m2, stiffness of this spring is k. Now suppose displacement of this mass from mean position is x1 and displacement of this mass from mean position is x2. While for derived equation I am assuming x2 is greater than x1. Na? So this is the mass 1, this is mass 2. So first I'm drawing the body of mass 1, which is displacing from mean position by x1. So we'll cut this spring from this location. Only one spring is coming now. Suppose this is spring 1. Okay, but the stiffness of this spring is important. It is K. Now here I'm drawing a body of mass 2, which is again displacing from mean position by x2. Okay. Here this spring is attached, which is spring 1, whose stiffness is K, and cut it from this location. Now firstly I am involving inertia force. So if displacement of mass 1 is x1, inertia force will be m1 x1 double dot, direction opposite to x1 double dot. Now if x1 is horizontal right, x1 double dot is also horizontal right, but inertia force is opposite to this, so it will be horizontal left. Now here inertia force, this mass is m2, its displacement from mean position is x2, so acceleration will be x2 double dot. Okay, direction of x2 double dot is same as x2. Then inertia force will be m2 x2 double dot, direction is opposite to x2 double dot. x2 double dot is this side, so it will be this side. Completed. Now restoring force or spring force. Firstly here, so only one spring is there, na, spring 1. Now what is the displacement of this spring? So it is coming between m1 and m2, and displacement of m1 is x1, it is x2. So displacement of this spring will be difference between them, but it will be x1 minus x2 or x2 minus x1. So right now we are assuming x2 is more than x1, so it is x2 minus x1. x2 minus x1 means it is dominating, and when mass 2 is going in this direction, it will try to elongate the spring. So ultimately, can I say net deflection of spring is x2 minus x1, and by that amount spring will elongate because this motion is dominating, which will try to elongate this spring. So can I say displacement of this spring is x2 minus x1, and when I am writing this, means by this amount it is elongating. So can I say spring force of this spring will be, stiffness is K. So K in bracket x2 minus x1, it is necessary tensile. So here this is the body of spring 1 in this part. So here spring force will come, which is K in bracket x2 minus x1, but direction, draw such arrow which will try to elongate this portion, because its nature is tensile, because it is elongating. Now to elongate this portion, we need to draw arrow like this. Similarly, this is also the body of spring 1, which is spring force is K in bracket x2 minus x1, but direction, draw such arrow which will try to elongate this portion. For that we need to draw arrow like this, which will try to elongate because it is elongating. Okay, yes. Completed. Now what we'll do, in body of mass 1, use summation of force in x direction equal to 0. So it will be, suppose I am adding this side force, so I will subtract this side force. So m1 x1 double dot, this side which I am adding. Okay, now this force, but we will subtract this because this side I am adding, so this side will subtract. So minus K in bracket x2 minus x1 is equal to 0. So it will be m1 x1 double dot minus kx2 minus plus kx1 equal to 0. So it will be first x1 double dot term, m1 x1 double dot, no x2 double dot term, then in displacement first x1 term, so plus kx1, then x2 term minus kx2 equal to 0. Suppose this is equation 1. Similarly, in FBD of mass 2, okay, we'll take again summation of force in x direction equal to 0. Yes. And while writing this equation, suppose again I am adding this side force and subtracting this side force. So m2 x2 double dot already this side which I am adding. So plus m2 x2 double dot. This force is also this side. So plus k in bracket x2 minus x1, which is equal to 0. So it will be m2 x2 double dot plus kx2 minus kx1 equal to 0. So no x1 double dot term. Now write x2 double dot term, which is m2 x2 double dot. Now in displacement first write x1 term, which is minus kx1, then x2 term plus kx2 equal to 0. This is equation. So now I can write this two differential equation in matrix form. In matrix form it will be mass matrix into acceleration means x1 double dot x2 double dot plus stiffness matrix into displacement x1 x2 equal to 0. Okay. Now, this term coefficient of x1 double dot in equation 1. In equation 1 the coefficient of x1 double dot is m1. This term coefficient of x2 double dot in equation 1, but in equation 1 x2 double dot is not coming, so it is 0. Similarly, it is the coefficient of x1 double dot in equation 2, but in equation 2 x1 double dot is not coming, so it is 0. It is the coefficient of x2 double dot in equation 2. In x2 double dot in equation 2, coefficient of x2 double dot is m2, so that's why it is m2. Similarly here, this is the coefficient of x1 in equation 1, and this is the coefficient of x2 in equation 1. Now you can see in equation 1 coefficient of x1 is k and coefficient of x2 is minus k, so it is k and minus k. Similarly, it is the coefficient of x1 in equation 2, it is the coefficient of x2 in equation 2. So in equation 2, coefficient of x1 is minus k and coefficient of x2 is k. So minus k and k. Yes. Now for frequency equation now, what we are doing? We are replacing x1 by capital X1 sine omega n t plus phi 1 and x2 by capital X2 sine omega n t plus phi 2. But you can write directly. So it will become now like this. First of all, m1 0 0 m2. Okay. Now x1 double dot will be minus x1 omega n square sine omega n t plus phi 1. It will differentiate this equation with respect to time 2 time. It will become minus x2 omega n square sine omega n t plus phi 2. But don't write sine term because it will get cancelled. So it is minus x1 omega n square capital X1 and minus capital X2 omega n square. But I am multiplying minus omega n square with this entire term. So then I need not to write here. So it will become minus m1 omega n square. It is 0 0 minus omega m2 omega n square. But that you can directly remember this step. Okay, plus. So it is already capital X1 sine omega n t plus phi capital X2 sine omega n t. Sine term I am not writing. So here already capital X1 capital X2 is coming. So I need not to change anything here. So it is k minus k minus k k. So finally equation will be, now both side capital X1 X2 is coming na. So just you can find final equation minus m1 omega n square plus k minus m1 omega n square plus k 0 minus k 0 minus k, so minus k minus m2 omega n square plus k. But you can directly write this. Just remember, when you are writing in terms of amplitude capital X1 X2 na, just here multiply omega n square, so it will be minus omega n square. So minus m1 omega n square, here 0 0 na 0 and minus m2 omega n square. Then here just add them, need not to change in any element. So plus k minus k, this minus k here and this plus k here. You can directly write. And after that we will write frequency equation. And frequency equation is determinant of this is 0, which is minus m1 omega n square minus k minus k minus m1 omega n square plus k, sorry k I love. It is minus m2 omega n square plus k is equal to 0. And determinant of this will be multiplication of these two minus multiplication of these two. It will be minus m1 omega n square plus k minus m2 omega n square plus k minus multiplication of these two. So minus into minus is plus, k into k is k square. So it is plus k square. This minus is already coming equal to 0. Now just expand this. So first of all, multiplication of these two. So minus into minus is plus m1 m2 omega n to the power 4. Yes, sir. Now multiply this term with this. So it is minus k m1 omega n square. Now I am multiplying k with these two terms. So multiply k with this. So it will be minus k m2 omega n square. Now plus k into k is k square and this minus k square equal to 0. Now again what I am doing, replacing omega n square by lambda. So it will be m1 m2. Okay, sorry, it was actually omega n to the power 4 na. m1 m2 omega n square means omega n to the power 4. Now omega, I am replacing omega n square by lambda, so it will become lambda square minus k m1 lambda. Okay, because omega n square I am replacing by lambda, na? So minus k m1, okay, minus k m1 lambda minus k m2 lambda. K square minus k square will get cancelled, that is equal to 0. Ultimately it will be m1 m2 lambda square, both will add, na? No, m1 m2 is coming. So what I am doing now, I am taking minus k lambda common, so it will become minus in bracket m1 plus m2 k lambda. This mathematics is your partner, equal to 0. So finally the equation which I am getting is m1 m2 lambda square minus m1 plus m2 k lambda equal to 0. Here you can easily find the root of this equation. Here take one lambda common, so it will become lambda in bracket m1 m2 lambda minus in bracket m1 plus m2 into k equal to 0. Now when this will be 0, when either this is 0 or this is 0. So we'll take this term 0, we'll get one value of lambda which is 0. So one value of lambda is 0, and lambda is nothing but omega n square. So can I say one value of omega n is also 0? Now equate this with 0, so it is we'll get another value of lambda m1 m2 lambda minus m1 plus m2 into k equal to 0. So m1 m2 lambda is equal to m1 plus m2 into k. So lambda will be m1 plus m2 into k upon m1 m2. Okay, and lambda is nothing but omega n square. So can I say omega n will be square root of this? Okay, omega n, I am writing this side, na, having less space. So omega n will be square root of this. So square root of m1 plus m2 into k upon m1 m2. So this is second natural frequency. Out of this, the value which is lesser is first natural frequency. So omega n1 is 0. The value which is more is second natural frequency. So second natural frequency is square root of in bracket m1 plus m2 into k upon m1 m2. So this is the value of two natural frequency for this question. One is 0 and another one is root over k1 plus k2 into, sorry, root over m1 plus m2 into k upon m1 m2. So I think option A is correct. You can check. Yes, option A is correct. So for this question, the correct answer is option A. So like this, you can find natural frequency. I think it is clear to everyone. Okay. Okay. So like this, we can find natural frequency. And if you understood this now, one question I am giving homework. This is homework. Because similar type of questions for this system, the value is given. K is 1250 Newton per meter, M is 10 kg. Okay, okay. So the natural frequency of the system, highest natural frequency, means you will get two natural frequency, omega n1, omega n2. So examiner is asking by about omega n2, means natural frequency which is coming more. So I think this type of question I had discussed now, so you will be able to solve this question. Okay. One more concept I am going to discuss here, which is the concept of mode shape. Sometimes examiner can ask, what is the first mode shape, what is the second mode shape, and what is the significance of mode shape, na? Okay, so to explain mode shape, na, again I am taking this question as my reference on I'm just copying this. Just see how to find mode shape na, if examiner is asking. See, for this question, this was the differential equation in matrix form. But if we are writing this equation in terms of amplitude capital X1, capital X2, if we are assuming that X1 is capital X1 sine omega n t plus phi 1 and X2 is capital X2 sine omega n t plus phi 2. That simplification I had done. So we were getting this equation. Now, I'm not explaining because this I explained. Minus m1 omega n square plus in bracket k1 plus k2. Yes. Minus k2 minus k2 minus m2 omega n square plus in bracket k2 plus k3 into capital X1 capital X2 equal to 0. Yes, clear? This derivation of this I have already explained. Okay, now okay, can I say if I will expand this, multiply this 2 with this, that will be equal to 0. Why I am doing this? To find mode shape. So first understand the step, automatically at last you will easily understand what is mode shape and how to find mode shape. Okay, so it will be minus m1 omega n square plus in bracket k1 plus k2 into capital X1 minus k2 into capital X2. This will be equal to 0. Okay. From this now, try to find capital X2 by capital X1. It is your will. If you want to find capital X1 by X2, you can find capital X1 by X2 also. If you want to find capital X2 by X1, you can find capital X2 by X1 also. I am finding capital X2 by X1. So can I say from this equation, you will find capital X2 by X1. It will be, shift this part this side, so plus K2 X2, bring K2 below side. So it will be minus m1 omega n square plus in bracket K1 plus K2 upon K2. So this will be capital X2 by X1. If you want, you can find capital, multiply this minus K2 X1 minus m2 omega n square plus K2 plus K3 into X2 equal to 0. One more equation you will get. Na? From that also you can find capital X2 by X1. Both will be same. Okay, since both will be same, so I am finding from this first equation, it is your will. So this is capital X2 by X1. Okay. Now what will happen now? If we calculate capital X2 by X1 corresponds to first natural frequency. That is known as first mode shape. What is the meaning of significance of first mode shape? I will explain, don't worry. Similarly, if I will calculate capital X2 by X1 corresponds to second natural frequency. Second natural frequency means when omega n is equal to omega n2. That is known as second mode shape. But what is the significance of mode shape? For that, now, firstly, for one case, now I am calculating this mode shape. So suppose I am calculating this mode shape for K1 equal to K2 equal to K3 equal to K. Otherwise, this will be lengthy, na? Similarly, I am calculating this for M1 equal to M2 equal to M. Okay. When I was discussing natural frequency also, now I have taken this case firstly as example. Now, if for this case we will find natural frequency, now this I have already found. You will get omega n1 equal to root k by m and omega n2 equal to root 3k by m. This solution I have already done. Similarly, for this special case, you will find capital X2 by capital X1. Just here put m1 equal to m2 equal to m and k1 equal to k2 equal to k. So it will be minus m omega n square plus 2k upon k. Clear? Now I am finding this capital X2 by X1 for omega n equal to omega n1, which is root k by m. And for this case, whatever this ratio is coming now, that is corresponds to first frequency. That I am representing as R1. In some book, it is represented as phi 1, but I am not taking phi 1 notation because phi 1 notation I am taking for phase angle. Okay, so R1 this R1 is nothing but x2 by x1 corresponds to first natural frequency. Now capital X2 corresponds to first natural frequency. For that, in above side I am using this mark 1. It is representing, we are calculating capital X2 by capital X1 corresponds to first natural frequency when entire system is vibrating with frequency omega n1. For that case, what is ratio capital X2 by X1, that I am finding. So definitely that will be equal to, if omega n is root k by m, can I say omega n square will be k by m, because here omega n square is coming. So replace omega n square by k by m. So minus m into k by m plus 2k upon k. M will get cancelled. Minus k plus 2k is plus k upon k 1. So here this capital X2 by X2 capital X1 corresponds to first frequency is coming 1. Yes. Firstly, I am finding for both the frequency. Similarly for second frequency. So for omega n is equal to omega n2, which is root over 3k by m. Now, if omega n is root 3k by m, omega n square will be 3k by m, and corresponds to this whatever value of capital X2 by capital X1 is coming now, that is R2. But this I am finding correspond to second natural frequency. So above side I am writing this 2. 2 means I am finding corresponds to second natural frequency. Okay. What this representing? Very simple. If it is vibrating with omega n2 now, this is the relation between the amplitude of mass 2 and mass 1. Okay. It will be equal to minus m omega n square, which is 3k by m plus 2k upon k. So will get cancelled. It will be, I think, minus 3k plus 2k means minus k upon k. It is coming minus 1. Yes. This is first mode shape. This is second mode shape. Sometimes examiner represent this mode shape in vector form also. Okay. In vector form, how examiner represent this na, in a matrix like this. Okay. See, can I say when capital X1 is 1, here writing, then capital X2 is also equal to 1. What I am trying to say. It is not necessary. If you want to write like this, you write like this, you can write also like this. 2, 2 or 3, 3. Minus 1. Both are representing same na. What I am trying to say, when capital X1 is 1, capital X2 is also 1 as per this. So this is first mode say. Okay. In this first mode say na, it is representing if system is vibrating with first frequency na, this is the relative relation between X1 and X2. Both are 1 means X1 and X2 are same. Okay, X1 and X2. If you want to write 2, 2, that is also correct. Minus 2, that is also correct. Minus 1, that is also correct. But generally examiner represent like this. Okay, it assumes it is 1. So what will be this? So it will be 1 into 1, that is 1. Okay, so this is first mode shape. Sometimes examiner write like this also, 1, 1 transpose. Transpose means again this is 1. Like second mode shape, if I are writing in matrix in vector form, it will be, just assume if capital X1 is 1, here capital X2 will be 1 into minus 1, that is minus 1. It is not necessary. If you are assuming capital X1 is minus 1, it will be 1, that is also correct. 2, it is minus 2. Minus 2, it is 2. All are correct. Okay, the relative ratio between these two, I am writing X2 by X1 means this butta this upon this should be minus 1. Ultimately, this should be ensured. So this is mode shape in vector form. But what is the meaning of this? That is important. Okay. So just I am drawing this diagram to explain. So first, for first natural frequency, can I say ultimately both X1 and X2 will come is same. What is the meaning of this now? If system is vibrating with natural frequency omega n1, and for this case X2 by X1 means for corresponds to first natural frequency, if this ratio is coming 1, means in this case na, displacement of both mass will always be same. Displacement of both mass will always be same. Means at any instant, if displacement of this mass is 2 centimeter this side, so displacement of this mass is also 2 centimeter this side. At an instant, displacement of this mass is 3 centimeter in this side, so displacement of this mass will also be 3 centimeter this side. Means if this mod shape ratio is 1 or R1 is 1, it means the displacement of both masses is always same. Means if I will draw the displacement equation for mass 1, that is x1, suppose if the graph is like this, so same graph you will get for mass 2 also, because displacement of both mass is same. Okay. If it is going this side by 2 centimeter, so this will also go this side by 2 centimeter. Same amount. If it is 2, it is also clear. Now at this instant, if it is displacement of both the masses is same, so can I say the displacement of this spring will be 0, because displacement of both masses are same. Sometimes examiner can ask, but this much of lengthy question will not come. Now here for this question, similarly, when I find R2, it is coming, means if system is vibrating with natural frequency 2, R2 is coming 1 minus 1. It means, or capital X2 by capital X1 corresponds to second natural frequency is minus 1. It means, can I say if displacement of mass 1 is 2 centimeter, displacement of mass 2 will be 2 into minus 1 means minus 2 centimeter. Means can I say the displacement of both mass are same but direction is opposite. Magnitude wise displacement is same but direction is opposite. Means what I am trying to say now, at any instant, if this point is going in this direction by 2 centimeter, so this point will go in this direction by also 2 centimeter. Clear? Direction is opposite, na? Means in terms of as a graph, if you draw, na, it is the graph of x1. Suppose if it is like this, see, when it is positive 2, it will be negative 2. So graph of x2 will be like, if it is vibrating with natural frequency omega n2. But you will ask, when it will vibrate with natural frequency omega n1 and when it will vibrate with natural frequency omega n2, that will depend how you are creating the vibration. Okay, because if you want to create the vibration, how I can create the vibration? First, for single degree of freedom I am explaining, I will displace this mass from its mean position, then release it, so it will vibrate like this. Okay, so see, now you will understand the significance of mode shape. If I am giving this initial displacement according to first mode shape, right now for this special case, first mode shape ratio is coming 1, means x1 and x2 are same. So if what I am doing now, if how initial displacement I am giving, so suppose to create the vibration, this mass I am displacing this side 2 centimeter and this mass I am also displacing this side 2 centimeters. I am taking x1 x2 same, means as per this information I am taking. After that, if I will release the mass, so now right now the before creating the vibration, the initial displacement which I have provided in the mass, it is as this ratio, so it will vibrate with frequency omega n1. It will vibrate with only frequency omega n1. Okay, yes. Similarly, if I am giving initial displacement as per this, means I am taking x1 x2 magnitude same but direction opposite. Means suppose I have moved this mass this side 2 centimeter and this mass this side 2 centimeter. After that, I have released the mass. So I have provided initial displacement as per this information. So in that case, it will vibrate with natural frequency omega n2. Clear? Natural frequency omega n2. But see, if you are providing the initial displacement in both the masses randomly, means neither I am following this nor I am following this. So in that case, the vibration which will occur in the mass that will depend upon the initial condition that we have to find. But in that vibration equation, means in the equation of x1 x2, both omega n1 and omega n2 will come. omega n1 and omega 2 means it will vibrate with the superposition of both the frequency. Okay, means if initial displacement, what I am trying to say, you are giving as per this information, it will vibrate with frequency omega n1. If information initial displacement we are giving as per this, it will vibrate with omega n2. But in initial displacement, I am giving random initial displacement. Suppose I have displaced like this, but didn't maintain any relation, so it will randomly vibrate. And in that vibration equation in that vibration, in the displacement equation, both omega n1 and omega n2 will come, because in that case vibration will be superposition of these two cases. Okay, so see, in the superposition of these two cases, if you want to write final displacement equation, that is equation of x1, similarly equation of x2. Now this much detail of question will never come in GATE examination, but just for understanding I am explaining. See, now I am assuming I am giving random displacement. Random displacement means it will vibrate with the superposition of omega n1 and omega n2. So how you can write the equation? So see, so here I am writing the displacement of mass 1. So first write, when it is vibrating with frequency omega n1, then displacement will be capital X1. First write sine omega n1 t plus phi 1. But see, when it is vibrating with frequency omega n1, but in this case this is the amplitude of mass 1, but it is the amplitude when it is vibrating only with frequency omega n1. Okay, and for that in amplitude I am using above said 1 na. 1 means it is amplitude when it is vibrating with omega n1. Okay, okay, now if it is only vibrating with omega n1, this is the equation of x1. Okay, but that vibration will occur when I am giving initial displacement by maintaining this ratio, but right now I am not maintaining this ratio. So what will be the equation of this displacement when it is vibrating with only omega n2? Omega n2, then equation will be capital X1, because I am writing for mass 1 na, sine, but frequency is omega n2 phi t plus phi. Like x1 equation I had taken na, capital X sine omega nt plus phi 1. So instead of x capital X1, sorry, capital X1, but instead of omega I am getting second natural frequency, and since it is corresponds to second natural frequency, here use it is amplitude of mass 1 corresponds to second natural frequency, and addition of these two is total displacement equation when it is vibrating with the superposition of these two. Clearly, again I am explaining. If we are writing this for mass 2, so see, earlier I had taken x2 equation was capital X2 sine omega n2 plus phi 2, but that was equation based on assumption it is vibrating with only one frequency. Okay, so equation was capital X2 sine omega nt plus phi 2. Now when it is vibrating corresponds to first natural frequency, it will be omega n1, and since it is corresponds to first natural frequency, here use 1. 1 means it is capital X2 corresponds to first frequency. Similarly, when it will vibrate with second frequency, again write capital X2 sine omega nt plus phi 2. But now when it is vibrating with second natural frequency, omega n will be omega n2, and amplitude capital X2 corresponds to second natural frequency. For that I am using this. This is the notation. Clear? So this is final equation of x1. This is the final equation of x2. If you write, you can replace this x21. For this question, x21 is 1 into x11. So you can replace, for if same question is coming, x21 by x11. Similarly, x22 is, as per this information, x22 is minus x12. So you can replace x22 by minus x22. But that relation with x22 is minus x12. So if you want, you can replace x22 by minus x12, but that will depend upon the question, na? But like this, if it is vibrating with the superposition of this and this, you can, frequency 1, frequency 2, you can write equation like this. Okay? So this is the final equation of displacement. I think it is clear to everyone. Okay. So I completed this discussion of 2 degree of freedom vibratory system. Generally question will come in which examiner will ask calculate natural frequency, that I explained. Sometime examiner will ask calculate this mode shape corresponds to first natural frequency. So what we'll do now, first find this capital X2 by capital X1, replace omega n by omega n, will get this capital X2 by X1 corresponds to first natural frequency, and write in vector form either this or this. Okay. Similarly, if you replace omega n by omega n2, you will get second mode shape. Okay, which is capital X2 by X1 corresponds to second natural frequency, but write in this form. It is 1 minus 1, or you can also write 1 minus 1 transpose. Clear? This is final displacement equation, but very rare question will come from this final displacement equation. Okay. Clear? So this chapter I completed. Just see this one question. Okay, actually now here it is omega n1, it is omega n2. This is mode shape. I was representing this as R1, this is R2. Okay. So if I am giving initial displacement as per this, means when x1 is 1, x2 is this. When x1 is this, x2 is this. Okay, okay. When x1 is double of this, x2 should be double of this. When x1 is 2, double of this. When the x1 is double of this, x2 should be double of this. So if I am giving initial displacement as per this now, it will vibrate with this frequency. If initial displacement is given as per this, then it will vibrate with this frequency. But if it is initial displacement is neither following this nor following this, then it will be the superposition of these two. Superposition of these two. Like see, here now it is saying if initial displacement is for 1 is this, for 2 it is the, then it will vibrate with second natural frequency. It's saying if in initial displacement like this, it will vibrate with first natural frequency. If initial displacement like this, it will vibrate with the combination of first and second. If initial displacement is like this, it will vibrate only with first. And see one important information, it is MSQ, not MCQ. So more than one option can be correct. So you have to focus in all the option, because since it is MSQ, more than one option can be correct. So see, in option A, it is saying that in case option A, if initial displacement like this, now it will vibrate with second natural frequency. So just see whether this displacement is following this vector or not. So see, if x1 is 6.32, x2 should be 3.16 times of this. Now see, 3.16 times of 6.32 is 19.97, but it is not 19.97. So this option is incorrect, because whatever is the frequency, but it will not vibrate with only second frequency. So A is incorrect. Now what about B? If x1 is 2, initially x2 is this, it will vibrate with first, only first. For only first means see it is following this or not. X1 is 2, so x2 should be 2 times of this. So 2 times of minus 3.16 means x2 should be minus 6.32. Same is written here. So it is following this, means it will vibrate only with first natural frequency. Same is written here. So B is correct. Now don't think if B is correct, A is incorrect, means C and D is also incorrect, because it is MSQ, so more than one option can be correct. So we have to focus in all the options. This is good question. Now if initial displacement is this, x1 x2, it will vibrate with the combination of first and second natural frequency. Means combination of first and second na, means this initial displacement neither it should follow this nor it should follow this. Means it will be combination of first and second natural frequency. So see, if it is following this, x1 is 2, so x2 should be 2 times of minus 3.16, means x2 should be minus 6.32. So this is not followed. Now what about this? If x1 is 2, x2 should be 3.16 times of 2, that is plus 6.32. Again that value is not here. Means it is following neither this mode shape nor this mode shape. Means it is the combination of first and natural second first and second natural frequency, and same is written here. That's why C is correct. Clear? Now D, if initial displacement this and this, it will follow vibrate with first natural frequency. Means it should follow this it is vibrating with first. So if x1 is 1, x2 should be 1 into minus 3.16 means minus 3.16, but different value is written here, means it will not vibrate only with first natural frequency. So D is incorrect. So for this question, the correct options are option B and C. It was very good question. So like this, you can proceed. Okay. So I completed this, but in YouTube, in 2 hours, I had tried to explain the various concepts. But you can understand, actually now to completely discuss the 2 degree of freedom vibratory system, at least I need to take the class of 8 to 10 hours. So that's why now I had not explained the concept in very detailed manner. I had taken some shortcut approach, but whatever approach I had taken now, you will not face any difficulty in finding the natural frequency and in finding the mode shape. You can easily find the equation of natural frequency, you can find the mode shape, and mostly these 2 type of question will come in the exam. Clear? So that's all from my side. Tomorrow I will discuss the concept of vibration isolation. Okay. So that's all for today. Now I am ending the class.